Okay, as we continue on to Chapter 6, Section 4, we're going to be dealing with rational equations. Now remember, we said rational expressions, another word for that, or a synonym, were fractions. So we're going to be dealing with equations that involve fractions. And as we mentioned very early in the course, whenever we have an equation, one of the first things we should do is to clear the fractions. And we clear them by, I usually refer to it as the least common denominator, or in a sense, the least common multiple. But we'll go over that and you'll see sort of how it fits in. So here are some examples. Oh, by the way, the matching, and those are the words, and they're pretty easy. Example 5 is a rational equation, as is 6 and 7. They're equations involving fractions. So the first thing we want to do is clear the fractions. And we do so by multiplying each term by the least common denominator. Now our common denominator here, what do you think it would be? Well, it's going to be 20. So we can do this a couple of ways, and again, there's different techniques, and what your instructor tells you to do, that is a good way as well. But I'd like to do it this way. A common denominator is 5 times 4. I'm going to multiply each term by the common denominator. And let's do that correctly. Oh, I guess I messed up on that one. And in fact, let's go through and figure out what our common denominators are. Then we'll solve the equations. So here we have a 5, a t, and a 2. So another way to write it, instead of writing it this way, would be 10t. Multiply every term by the common denominator. And what's our common denominator here? Well, notice here we're going to have to factor that, and that's going to be 2 times x plus 2. So x plus 2 is one of our common denominators, but we're also going to need an 8. 2 will go into 8. So our lowest common denominator for this is going to be 8 times x plus 2. Now this is like a super important step in working out rational equations. You have to clear the fractions. And that's what we've been building up to in our Chapter 6 work. So now, what do we do? Well, we're going to multiply each term by our lowest common denominator. So here the 5 will cancel out nicely. Here the 4 cancels out nicely. And here we have 20 times 9, which is going to be 180. So nothing cancels out there. But notice now, we only have 1s in our denominator. So we don't have fractions anymore. And then here the other technique is 5 will go into 10 once. Well, 5 will go into 5 once. 5 will go into 10 twice. And now there's a 1 there, but we have a 2t yet to handle. Here t will cancel with the t, so we still have the 10 there. Here the 2 will cancel with the 10, and that gives us a 5t. And let's not get too far, so let's do this. So we have, what's left here is 4x, so 4x plus 5x equals, again, 20 times 9 is 180. So we're going to group like terms. This gives me a 9x equals 180. We're going to divide both sides by 9, so x equals 20. So that was sort of an easy one. And let's do this. So we've got rid of all the fractions by multiplying every term by the lowest common denominator. So now we have 2t times 2. That's going to give me 4t. Now notice we have a minus there. So this is a minus 10. And here we have a 5t. Now we want our t's to be positive if we can. So we're going to transpose the 4t to this side. Becomes a negative 4t. So this leaves me with just a t equals negative 10. So both of those were pretty easy. Now let's get to number 7. That's more the challenge here. Well, we're going to cancel now this with this. The 8 cancels there. And here we're going to cancel this with this. The 2 goes into there once, and here we're left with a 4. Now notice all of our denominators now are 1. So we've gotten rid of all the fractions. We're clearing fractions. And now we have to write our equivalent equation without fractions. So here we're left with an 8. 8 times 4 is 32. Plus 5 times x is 5x. 5 times 2 is 10. Equals 4 times 3 is 12. So notice we have a much easier equation than what we started off with by clearing fractions, by multiplying everything by the lowest common denominator. That got rid of our fractions. So now we just group like terms. This becomes a 5x plus 42 equals 12. We're now going to transpose the 42, becomes a negative 42. This is a negative 30. We divide both sides by 5. X equals negative 6. And there we go. Not too bad. Okay, going on to examples 8, 9, and 10. Now to save a little time, I'm putting up some of the work. Otherwise the tapes get to be too long. So here we have a 9, a 4, and a 12. And we're looking for a common denominator. Well, 4 times 9 is 36. 3 times 12 is 36. So our common denominator is 36. Here is just the x, so we multiply every term by the x. Again, we're clearing fractions. And then here, this is n plus 1, n plus 1. So n plus 1 is our common denominator. So now 9 will go into 36 4 times. 4t goes into t once, and 4 goes there 9. 12 goes into there once, goes into there 3 times. So now all of my denominators are 1, and I have to just get an equivalent equation by multiplying through. So 4t3, that will be 12t. Don't forget we have a negative there, so this is a negative 9. And there's a t there as well, so that's going to be 12t. Uh-oh, something's going to happen here. Notice that if I subtract 12t from both sides, I get negative 9 equals 0. Is this a true statement? No. And what did we say when we ended up with a not a true statement? That there was no solution. Or we said it's an empty set. All right, for number 9. Looks a little easy, and you're going to get some like this, I'm sure. Here the x's cancel out. So we're left with x squared plus 10 equals 7x. Ah, this is a quadratic equation. And how do we solve quadratic equations? By putting them in standard form. And let's do that. X squared, bring this over, negative 7x plus 10 equals 0. And once they're in standard form, how do we solve them? By factoring. X, 5, 2, negative, negative. So what is your solution set here? X is going to be a positive 2. X is going to be a positive 5. There's our solution set. Again, not too bad, just using some of our techniques. So for number 10, these cancel out nicely. And we get 3, let's see, n plus 3 equals 2. So we're going to transpose that, becomes a negative 3, so negative 1. Uh-oh, problem here. Now, can negative 1 be a solution for this equation? Ooh, here we're talking about domain. What's the domain of this negative, this n term? Can it be a negative 1? No, if a negative 1 is there, it's going to make this undefined. So our domain of this would be, n could be any real number, but n cannot be equal to negative 1. And that's what it's equal to. So, for number 10, the answer is an empty set or no solution. And why is that? Because when we solved it using our technique of clearing the fractions and getting an answer, taking this answer, checking it, it would make the example undefined. So there's no solution. Okay, we're going to spend a little time on this slide so that as we look at it, again, they're all rational equations, and we need to figure out what's our least common denominator. And our least common denominator here after we factored this, was t and then t plus 3. So that's what we have to multiply every term by. T plus 3. T plus 3. So I'm multiplying each term by my lowest common denominator. Remember, what you put up here has to get rid of your denominators down here so they eventually become a 1. And then as we look at this, our common denominators here, we can't factor anything, so it's going to be 2x and then 3x plus 4. And again, 2x and 3x plus 4. And as we look at 15, starting to get a little complicated, but if we factor this, it actually factors into this. So our lowest common denominator will be this factored, which we'll write over here. X minus 1, x plus 2. X minus 1, x plus 2. And then here, x minus 1, x plus 2. We know all of this is going to cancel out, but we're setting up, again, a method to do these, a strategy. So, we now go and do some canceling. Here I want to get my green here. There it is. The x plus 3 will cancel with that. Here, all of this cancels. And here we're left with t times t is going to be t squared. And t squared here is going to equal 9. And to put that in standard form, I'll save a little room and I'll put it here. T squared minus 9 equals 0. This is the difference of perfect squares, which will factor into its conjugates. So the answer set of this one will be 3 comma negative 3. Or you could have reversed that there. Now, when you do this, and if you were to put this into MATLAB, an interesting thing happens. They're going to say it's wrong. And you might say, why is it wrong? Well, remember, if t is a negative 3, if you put a negative 3 there, that's going to make this denominator a 0. So you can't use negative 3. So even though it came out in the solution, you have to, in a sense, check your answers, because negative 3 is not a satisfactory answer. It makes this denominator a 0. So a negative 3 is not in that domain. And you might put a little star by this so that as you look at your notes, you go back and say, oh, yes, okay. All right, let's do this one. We already have the LCD here. Here, this cancels out nicely. And this will cancel out nicely. So now we have to go 2x times 2 is 4x. And then we got to do 5 times 3x, which is 15x. And 5 times 4, which is 20. And we're going to transpose the 4x to this side. Becomes a negative 4x. This gives me an 11x. Transpose this gives me a negative 20. Divide both sides by 11. x equals a negative 20 over 11. And remember, they usually like to put the negative sign out there, but up there is good too. All right, let's do some canceling here. X minus 1, x minus 1. X plus 2, x plus 2. This is nice. All of this cancels. So we're now left with 5x plus 10 minus, now there's a minus if we just change the signs, negative x plus 1. Oh, we got to times that by 6 though. So it's going to be a negative 6x. Sorry about that. Negative 6x. That's going to be a positive 6. Okay. So another way to do it would have been to put the negative 6 up over there. And then that way you get your answers. You've got to be careful of the signs. And then this is just going to be equal to 3x. So again, I would follow the strategy, collect like terms. So over here it looks like a negative x plus 16 equals 3x. Just collecting like terms. And now we're going to keep our x's positive, bring this over, becomes another x, so this becomes 4x. Divide both sides by 4. X equals 4. Okay, so at least it's colorful. Okay, for the last two that we're going to do, they're introducing again function notation. And in function notation, they're saying this function is in a sense equal to this. So we just set it up as a basic equation. And our common denominator is x. So here we get 2x squared. Here the x's cancel out, plus 3. I'm going to put that over here because this is going to be a 7x, but I'm going to put it in standard form, bring it over. And then I get a quadratic equation in standard form. So I just sort of eliminated one step, but I think mentally you can do that. This 7x was on this side, brought it over as a negative 7x. The 3 is there, I just made room for it, and now we factor. So 2x, x, 3 and 1, and they both need to be negative. So when I FOIL, that checks. A negative 6x, a negative 1x, add up to a negative 7x, my last positive 3. So my answer set will be, this is going to be a positive 1/2. Transpose that, divide by 2, and this will be a 3. All right, for this one, again, it's set up similar. It's function notation, where this will equal that, and we set it up as an equation. Our common denominator will be a 3 and an x minus 1, which I've put in red. This now cancels. This cancels. So now I get 3x plus 15 equals 2x minus 2. I group like term, well, we don't have any. I'm going to transpose this, this just becomes an x. Transpose that, and that becomes a negative 15, so negative 17. And that is my answer. Okay, so again, there are some more challenging ones. I didn't want to make it too long, but this is the style, the strategy of how to get that. So 6.4, we'll be working on 6.5 shortly.